Our planet holds a remarkable hidden treasure. Deep within the continental crust, vast quantities of hydrogen gas have been naturally produced. This is not a small amount. Scientists estimate this hidden hydrogen could be immense. It might be enough to meet current global energy needs for thousands of years. Some studies suggest a potential equivalent to 170,000 years of our present societal oil use. This discovery opens a new door. It points towards a future with cleaner energy, if we can harness it. The implications are truly staggering for our energy landscape. This natural hydrogen is not a recent arrival. It has been forming over the ages. Several geological processes create it. One key process is called serpentinization. This happens when water reacts with iron-rich rocks deep underground. Another method is rock fracturing, which can release trapped hydrogen. Radiolytic water splitting, where natural radiation splits water molecules, also contributes. Importantly, this accessible hydrogen is found in the crust. Hydrogen from Earth's deeper mantle is not considered a viable source for us to exploit for energy. However, there's much we still do not know. A large portion of this ancient hydrogen has likely vanished. Some of it may have escaped into the atmosphere over geological time. Subsurface microbes are also known to consume hydrogen as their energy source. Therefore, the actual amount that remains preserved is uncertain. We are not yet sure how much is in accessible, economically exploitable reserves. Finding societally important reserves is still a goal. The true scale of this resource is a big question. The potential is enormous, but so are the questions. We need to understand where to look for these deposits. We need to know how much is truly there, and we need to figure out how to extract it safely and economically. The idea of a clean, abundant energy source is compelling, but the journey from discovery to widespread use is long. Scientists are now focused on the next steps. They are trying to map out this hidden resource. The challenge is great, but the reward could reshape our world. To find this hidden hydrogen, we need a guide. A new study offers just that. Researchers from the University of Oxford, Durham University, and the University of Toronto have collaborated. Their work was published on May 13, 2024. They have detailed what they call an exploration recipe. This recipe is a set of guidelines. It helps identify locations where natural hydrogen might have accumulated. This scientific roadmap is crucial for future exploration efforts. It provides a systematic approach. The recipe outlines key geological requirements. For hydrogen to gather, specific conditions must be met. First, there must be a source rock. These are rocks capable of generating hydrogen through processes like serpentinization. Second, suitable reservoir rocks are needed. These rocks must be porous and permeable enough to store the hydrogen. Third, and very importantly, there must be effective natural seals. These are often layers of impermeable rock, like shale or salt, that trap the hydrogen gas and prevent its escape. Fortunately, these necessary conditions are not unique to one place. Scientists believe they can exist in many parts of the world. In the United States alone, at least 30 states may have such geological settings. These settings can be found in rocks of various ages. Some are geologically young, others are more ancient. This widespread potential means that many countries might have access to this resource. It suggests a decentralized energy future. However, finding these perfect spots is complex. Professor Chris Ballantyne from the University of Oxford compared it to cooking a souffle. He explained that all the geological conditions must be just right. The temperature, the pressure, the rock types, and the timing all matter. If one ingredient is off, the hydrogen may not accumulate or be preserved. This highlights the precision needed in exploration. It is not as simple as just drilling holes. It requires deep geological understanding and careful investigation. The search for natural hydrogen is now focusing on specific geological areas. Ophiolite complexes are one promising target. These are sections of oceanic crust and upper mantle thrust onto continents. In 2024, a significant hydrogen reservoir was discovered in an ophiolite in Albania. This discovery has boosted confidence. Large igneous provinces, which are vast areas of volcanic rock, also show potential. Archean greenstone belts, ancient rock formations, are another area of interest. Even features like the mid-continental rift in Kansas are being explored. A major challenge in this hunt is the presence of underground microbes. These tiny organisms are very efficient at consuming hydrogen. For them, hydrogen is a vital source of energy. This means that if hydrogen is produced in an area teeming with microbial life, it might be quickly used up. Therefore, for hydrogen to accumulate in large quantities, it needs to be protected from these microbes. This biological factor adds another layer of complexity to exploration. We are not just looking for rocks. We are looking for sterile environments. Exploration strategies must therefore be clever. They need to target geological formations where hydrogen has been isolated. This means looking for reservoirs that are sealed off from microbial activity. Perhaps the cap rocks that trap the hydrogen also prevent microbes from reaching it. Or maybe the specific chemical conditions in some reservoirs are hostile to these organisms. Understanding these underground guardians of hydrogen is key. Successful exploration will depend on finding these naturally preserved, microbe-free pockets of gas. The exploration recipe developed by scientists helps in this regard. It guides researchers to look for these protected zones. By understanding the source, reservoir, and seal, explorers can better predict where hydrogen might be safe. This makes the search more targeted and less like a random treasure hunt. The goal is to find hydrogen that has been kept safe for ages. This careful, science-driven approach is vital. It increases the chances of finding economically viable deposits of this clean fuel. The world needs more hydrogen. In 2023, global hydrogen demand reached 97 million metric tons. This demand is not static, it is growing rapidly. Projections suggest it could rise to around 540 million metric tons by the year 2050. Currently, the hydrogen market is valued at about $135 billion. It is primarily used for making fertilizers and in chemical industries. But as we seek cleaner energy, its role could expand dramatically. Some analysts predict the market could grow to an astonishing $1 trillion by 2050. Today, how we make hydrogen is a problem. Nearly all hydrogen is produced from hydrocarbons, like natural gas and coal. This process, often called gray or blue hydrogen production, releases a lot of carbon dioxide. In fact, it contributes about 2.4% of global CO2 emissions. That is a significant environmental footprint. Only a tiny fraction, about 0.1%, of hydrogen is currently produced using green methods. These green methods, like electrolysis powered by renewable energy, are climate neutral, but often more expensive. Natural geological hydrogen offers a compelling alternative. If found in economic quantities, it could be a truly clean source. It is already there, made by the Earth itself. Extracting it would not involve the CO2 emissions of current methods. This gold or white hydrogen could be an emission-free fuel. This is a powerful incentive for exploration. It aligns perfectly with global efforts to decarbonize our energy systems. The environmental benefits are potentially enormous, reducing our reliance on fossil fuels for hydrogen production. The researchers behind the exploration recipe are optimistic but cautious. Professor John Gluyas of Durham University and Professor Barbara Sherwood Lawler of the University of Toronto are key figures. They, along with Professor Ballantyne, have formed Snowfox Discovery Ltd. To explore for natural hydrogen. They are not alone. Companies like Coloma, backed by Bill Gates's Breakthrough Energy Fund, and High Terra, funded by Fortescue, are also in this emerging field. Snowfox itself is funded by major players like BP and Rio Tinto. Further research is still needed. We need to understand rock reaction efficiencies better. We must unravel the geological history that brings hydrogen-generating rocks and water together. The path is complex, but the potential for clean energy is a powerful motivator.